Take a deep breath, let your eyelids fall softly. For a moment, picture the familiar arc of a rainbow. Red, orange, yellow, green, blue, indigo, violet. It feels like the complete story of colour. But tonight, I want to take you beyond that edge, past violet, past red, into a world of invisible colours that fill the air around you right now. Welcome to another episode of Night Lamp Curiosity. I'm Professor Photon, and tonight we are going to discover colours beyond the rainbow. Stay with me until the end, because by the time you drift into sleep, you'll realise the rainbow you know is only a single octave in a cosmic symphony of light. The colours you see are not things that exist out there. They are sensations, the brain's translation of electromagnetic waves. Light is a form of energy that travels in waves, and each wave has a wavelength, the distance between peaks. Your eyes are tuned to a narrow band of these wavelengths, between about 400 and 700 nanometers. A tiny slice of the electromagnetic spectrum. That's the rainbow. Violet with its short, quick waves, red with its long, slow ones. But the universe doesn't stop there. On one side of violet lies ultraviolet, light so energetic that it can break molecules apart. On the other side of red lies infrared, light so long and gentle that it carries warmth instead of colour. And beyond those edges stretch worlds of microwaves, radio waves, X-rays and gamma rays, invisible, yet everywhere. If your eyes could see the full spectrum, the night sky would blaze with invisible fire. Let's start with the warmth we feel but cannot see. Infrared. When you hold your hands close together without touching, you feel a soft radiance between them. That's infrared light. Every warm object emits it. The hotter it is, the more it glows in this hidden hue. Your body right now is shining in infrared, painting invisible patterns into the air. Thermal cameras can see them, revealing rivers of heat across skin and air currents. Snakes, like pit vipers and pythons, use infrared vision to hunt in darkness. They have tiny heat-sensing pits between their eyes and nostrils. Natural infrared detectors that can sense a mouse's warmth meters away, even on the coldest night. For them, the world glows with warmth, where we see only shadow. Firefighters use similar technology to navigate smoke. Astronomers use infrared telescopes to peer through cosmic dust and see stars being born inside nebulae. To human eyes, those clouds are opaque. In infrared, they open like curtains revealing newborn suns. Infrared is the colour of warmth, the signature of life, the glow of beginnings. Now move to the opposite end. Ultraviolet, the light beyond violet. These waves are so energetic that they can damage DNA. That's why sunburn happens. Ultraviolet radiation breaking the bonds in skin cells. Yet life has learned to use UV in wondrous ways. Bees, butterflies, and many birds see ultraviolet as clearly as we see blue. The black-eyed Susan that looks simple yellow to us is, in ultraviolet, a target with radiant lines pointing toward its centre. A runway for pollinators. What to us seems ordinary is, to a bee, a glowing signpost. Some flowers even change their ultraviolet patterns after being pollinated, signalling to insects, "My nectar is gone, visit another." Nature paints messages in colours we'll never see. Reindeer see ultraviolet too. In the Arctic, that ability helps them spot lichens, their food, which absorb UV and appear dark against the snowy landscape that reflects it. For them, the world glows with hidden maps of survival. Even scorpions glow electric blue under UV light, a strange, ancient trick of molecules in their exoskeletons. Scientists aren't certain why, but one theory suggests it protects them from harsh sunlight or helps them sense exposure at night. Under the desert moon, they are living lanterns. Between infrared and ultraviolet lies the world we know. But beyond them stretch the rest of the invisible spectrum. Microwaves, for instance, are longer than infrared and carry less energy. You know them as the waves that heat food, but they also come from the stars. In 1964, Two engineers, Arno Penzias and Robert Wilson, were testing a radio antenna and stumbled upon a faint hiss of microwave noise from every direction in the sky. That hiss turned out to be the cosmic microwave background, the afterglow of the Big Bang, the oldest light in the universe. Every time you reheat your tea, you use the same type of waves that once filled the newborn cosmos. Radio waves are even longer. They can stretch for kilometers and carry voices, music, and data around the planet. Lightning storms on Jupiter and quasars billions of light years away all send radio whispers into space. Astronomers use massive dish antennas to listen, turning invisible waves into images and sound. In a sense, the universe is constantly speaking. We've just learned how to hear it. Now move the other way along the spectrum, past ultraviolet, into the dangerous brilliance of X-rays and gamma rays. X-rays slip through flesh but bounce off bone. A discovery by Wilhelm Röntgen in 1895 that revolutionized medicine. He captured the first X-ray image. His wife's hand, her bones and wedding ring glowing like a ghost. In astronomy, X-rays reveal violent places, the hearts of galaxies, the edges of black holes, and exploding stars. They show us the universe at its most energetic, where matter and light wrestle. Gamma rays are even more extreme, photons born in nuclear reactions and supernovae. For a brief instant, a single gamma ray burst can outshine entire galaxies. Astronomers believe some of these bursts mark the birth of black holes. They are the universe's thunderclaps, rare, invisible, and incomprehensibly powerful. Yet here's the wonder, despite their violence, these same rays tell us that creation and destruction are one rhythm, one cycle. The energy that tears atoms apart also lights up worlds. So, from the longest radio waves to the shortest gamma flashes, the electromagnetic spectrum spans an unimaginable range. A trillion frequencies, all vibrating through the same space we breathe. Right now, you are immersed in it. Radio broadcasts, Wi-Fi, cosmic background radiation, starlight. You're bathed in invisible colour. The darkness around you is not empty. It's saturated with light you cannot see. Our eyes evolved to read only a middle octave of that grand scale. Perhaps because sunlight's peak output matches it, or because water and atmosphere absorb much of the rest. In other words, our perception is tuned for survival, not completeness. Nature gave us a narrow window, enough to find fruit, friends, and fire. But beyond that window, reality continues endlessly. If we could see the entire spectrum, night and day would disappear. Everything would glow. Your phone would shimmer with radio light. Your body would bloom in infrared warmth. The air itself would pulse with microwaves. The sky would blaze with ultraviolet threads and cosmic rays. We live in a painting far richer than our senses allow. And perhaps that's merciful. If we could see all frequencies, we might be blinded by the constant symphony of existence. Instead, we glimpse just enough to wonder. Artists, mystics and scientists have long tried to stretch that vision. The painter Claude Monet, after cataract surgery, reported that his vision changed. Colours shifted. He saw new violets and ultraviolets reflected in water lilies that had never shone that way before. Science caught up later. Removed lenses can indeed allow UV to reach the retina. Monet had literally glimpsed beyond the rainbow. Astronomers do it with instruments, radio telescopes for long waves, X-ray observatories for short ones. When the data are translated into visible colour, we get images like the Pillars of Creation, the Andromeda Galaxy, or the Carina Nebula. Each a symphony of invisible light converted into our limited spectrum. Every false colour image you've ever seen from NASA is a translation, turning frequencies we can't see into ones we can. They're not fake. They're our best attempt to make the invisible visible. And here's a quiet truth. Perception defines reality. Your cat sees in low light with eyes tuned toward blue and green. A mantis shrimp sees with 16 color receptors. Humans have only 3. It can perceive polarized light, ultraviolet, and patterns we have no words for. For it, the ocean is a cathedral of radiance we can't imagine. Meanwhile, bats see with sound, snakes with heat, dolphins with ultrasound clicks. Every creature inhabits its own sensory universe, its Umwelt, as biologist Jakob von Uexküll called it. Each is surrounded by its own version of reality, overlapping but distinct. So the rainbow we see is not the rainbow itself. It's our small, beautiful translation of a much grander song. As you lie here now, the room dim and quiet, know that you are surrounded by light in every form. Waves of warmth, whispers of radio, the ancient hum of cosmic birth. You are not in darkness. You are swimming in hidden colour. Close your eyes and picture that. A gentle red ocean of heat from your body, blue-violet halos around the edges of stars. Gold microwave ripples drifting through space since the dawn of time, and far beyond, gamma flares, radio tides, ultraviolet rivers, all threading through you, through this planet, through the universe, all of it light, all of it colour, all of it whispering the same word in infinite tones, existence. Thank you for staying till the end, and good night.